Today I'm going to talk about decomposing distributed monolith. I'm going to explain what that means actually. And the thing that Node.js, hopefully none of you came just for Node.js, because it's not the key, of this talk. It's more of a coincidence, the thing that we in Wix introduced as a second stack. But there will be some Node code. So hi, I'm Vilius from Wix engineering offices in Vilnius. Who of you have heard about like Wix? Oh shit, that is nice. I mean, I won't have to explain then much. So Wix is a SaaS company, 100-something million users, doing some good and not so good stuff. No, good, only good, of course. And yeah, I'm working in Wix for 3 years now. I joined as a backend engineer, or actually there was the guild master thing. So yeah, we use the Spotify model somewhat, and the way I define guild master is playing coach, žaidžiantis treneris. But for the last couple of years, actually I was hired for JVM and Scala, but actually I was working on Node.js for the last 2 years and moving to even like front-end development somewhat. But for the last couple of years, I was actually mostly writing code. So today I'm gonna walk you through what is a short introduction, what is microservices, and what the hell is distributed monolith. Then, why am I talking about this thing at all? And then I'll guide you through the history, through my experience of introducing a second stack at Wix, and then the composition part. Who of you are actually doing microservices or working, on the products based on microservices? Not too much, okay. So this is not actually a talk about microservices, but as Martin Fowler puts it, microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, HTTP or something similar. So yeah, it's not a secret. In Wix we do microservices. I think now we have, or we think we do microservices. That there is might be a slight difference there. Now I think we have around 500 microservices in production. I don't know exact number. We stopped counting after, I don't know, 150 or something. So multiple data centers and all that. So the scale is interesting, I would say. I cannot say it's big or not big. It's really depends on who you compare it to, but it is interesting. Now, what is a distributed monolith in the context of microservice architecture? So it's a form of a binary coupling where in order to interact and coexist in a given system, you are required to use a set of official libraries, where the required is the important word. And this is the case where in order to talk to a service, the client, that service's provided library is the only official way actually to communicate to it. What's wrong with it? Because like service provider was really nice, build you this nice library so you don't actually need to write any boilerplate code. He's like helping you. Well, there are a couple of potential issues there. One is that actually the logic of a service tends to drift to a client library. Be it like, performance optimizations, some caching, something. He's, again, trying to be nice to you. And another one that can potentially, and really happens in these cases, that service API which initially started like reasonable API of a service, starts becoming opaque. Because nobody now thinks about this service and its API as a consumable thing for like developers, but just as a means to get or push data for the client library. So in the end, it becomes pretty much unusable in itself. And then it becomes nearly impossible to adopt new architectures, languages, in your organization. Because if you, or in your service, microservice group, because if you have like tens of these official client libraries, which are, let's say, Java-based, you cannot move to Node.js anymore, because what do you do with them? You need them to do your job, but then you are locked to JVM ecosystem. Then again, for example, in JVM, you get problems like transitive dependencies. If your client library depends on Guava's some version, then you cannot actually use a different version. You depend now on the client library. It like manifests what you have to use, or you have to go and talk to them to go, like, hey, upgrade your version. I need that new stuff there. And even things like you want to go to a different threading model, from like threads to green threads, lightweight something, but this client library for every request spawns a thread and does something. So like you cannot do it anymore. The client enforces your architecture. And it's not impossible, of course, but cost-wise, it might be really just like, no, we won't do it. But hey, do not repeat yourself. Code reuse. This is good, right? The client didn't want for every consumer to do something, so like to rewrite same boilerplate code. So he built a client library to use to enable code reuse, and these are good things, but. The evil of too much, as like Sam Newman puts it in his like amazing book, Building Microservices, the evil of too much coupling between services are far worse than the problems caused by code duplication. And potentially this is not something you really want to prioritize in microservice architecture, the code reuse. Because you potentially lose polyglot. Again, if you have those official libraries in JVM, you cannot, and like there is new thing that makes sense in your architecture for some problems to solve, you not necessarily can use it. You are locked in. Then organization, technical decoupling. So that teams can evolve technically without coupled collaboration between them. So I can do my thing and don't need to talk and deal with any of my services that I actually use. And temporal decoupling. Can I make you might not be able to make decisions in your service, like it's your thing. And to do it independently from the clients that enforce their decisions upon you. Okay, so if maybe some of you agree that it's bad, this distributed monolith thing, what is the alternative? Contracts and protocols. It's how internet is built. So that APIs you can consume with any language. There are clear, well-defined and like standard protocols, clear contracts. You can change and iterate over time. And also there is no dependency on client implementation. Yeah, but there are these things like central logging, distributed tracing, context passing. So this is, let's say, distributed tracing. So that microservice architecture there is a call, and it goes through a bunch of services, and you want, for debugging, for whatnot, you want to be able to figure out, you know, what happened in case of some problems, where it went, where was the failure. So everybody needs to participate. I mean, either all services are in, or this thing breaks at some point, and you just don't have it. So again, you know, with official libraries and everything, it's easy to enforce. And you don't need actually binary coupling to get these things. Same, standardization via protocols and contracts, and independent libraries. So this is the really good thing and important, because if a service provider gives you official library, then he can, you know, couple them and really move logic forth and back. If somebody builds independent library, then service provider is not responsible to it, cannot enforce it. It's just a helper somebody built to, you know, enable code reuse. And compliance contract test. So this is automated tools that basically can verify if your services are compliant to run in production. Like, you know, some sort of test suite or some means that can say you're good, you're passing the context, for example, or you are participating in distributed tracing. I know something interesting Uber is doing in that sense, because they really initially they had like a zoo of everything. Whatever language you want to use, whatever, and they have issues now, but they added this, so before going to production, you can verify that your service can actually, you know, be a good citizen there. And this is, yeah, this is one of the tools to mitigate that, you know, issue. Now, when you're doing microservices, and to diagnose if you suffer from distributed monolithitis, you have to answer to two following questions. Does it take months to upgrade a library across company? Yes, so for us, sadly, it was yes. Jackson, we JVM, so we use Jackson for something, and actually we did have to answer yes to this question. And does it take a year or close to it to introduce a new stack to organization, to production, I mean? And this is, again, I can say yes, because I was working on it. And we're in production, but not near we're done. And this is actually what I'm going to concentrate on. So introducing a Node.js stack at Wix. When we started, basically like some projects started experimenting with Node.js and possibility for client developers to actually build their services. You know, like, why not? You can reuse code, they can better, like, there are many benefits. And initial, like, manifesto was, target of this project is to enable coding front-end servers in Wix using Node.js. We're aiming at the pattern of front-end servers. So same pattern, as far as I know, was adopted by Netflix. Like front-end servers, they experimented with that. So we're not like, leading there. We looked at it, industry was doing that, and we said, it makes sense. There were some other benefits that came in afterwards. We didn't think about that, like React server-side rendering and some other things. But actually, it played out that, we started it, and it worked really well for us. And Yoav is architect at Wix. Okay. So given wait, is there a light? Ooh. Given pre-Node.js state at Wix, basically some simple app looked like a JVM service which serves, your client, like renders client, and exposes HTTP APIs for the client to get and push data. Then it can talk to message queues, databases, and also via RPC talks to a bunch of other microservices in Wix. So as you can see, it was all JVM, one big happy family. And the goal of the project was, Node.js there. Doesn't look too hard, right? You just swap one piece from the puzzle, and how hard can it be? Well, let's walk through one example that I discovered that we were doing. So usual request path from the system is, client, the browser sends a HTTP request, then Node.js service takes it and wants to issue a call to a microservice within Wix, an RPC call. All good. Actually, we were using JSON RPC2, which is standard, and has like a spec around it, so no in-house crazy stuff. But, oops. It turns out that we actually were creative there. And in addition to the spec, we also passing headers, cookies. Well, headers and cookies travel naturally, from browser, but then we do transform them, pass down the line to get all the distributed context and like some homegrown signing of requests for security, and then headers have to be pushed back and written as a cookies. So like, not too bad, but there was really some work there. And that wasn't the worst part. This is a service. I mean, it's not really clear, but and we have another service, like one of our core services, P3. This is our A/B testing system. So all the services, apps can, do experiments and A/B tests, and turns out that this really nice and polite service was actually having really fat, chubby client in every microservice. So when you all JVM, it's not actually a problem. But now when you're adding a new stack, you have to re-implement it or just deal with it somehow, because not having A/B tests in Node was not an option. And it gets better. It turns out we had more of a polite services, which talk to some context within service, like for exchange info, and even like, talk to each other, like chatting something for good reasons. I mean, not just because, but yeah, now this needed, again, in JVM it was not a problem, but now it needed to be solved somehow. And then ops contracts. What the hell is that, right? This is basically, I tried to draw a state machine for our health detection status, and it's implemented in code, and it's not too terrible, but then there are timing and retries. Basically, it all makes sense. Given we run in cloud, multiple data centers, things can be flaky, and we want services to like be resilient there. So this all makes sense. But again, like if we would have had polyglot system before doing this, I think we would have just moved this to infrastructure somewhere, just not really implement in the code. And then the problem just wouldn't exist. Again, not always bad. Just build deploy pipeline was already set. I don't know if I'll come back. I don't know if I mentioned, but basically, I was pretty much a solo developer on the effort to add Node.js and to, building infrastructure. Like I think I wrote close to 90% of the code there. And the project was, I didn't have a project manager or something. It was like, hey, you know, we want to try this out. Do you want to do it? Okay. So, you know, so I'm walking through from that perspective. And this thing was really good because whatever was wrong, I had to implement it and fix it, right? So if I find something that is good, I'm happy about it. So again, build deploy pipeline already had support extensions for non-official stacks, so I'm good, don't have to write any code, I'm happy. Contracts for deploying application was defined, saying simple. Again, there was a documentation even for that, you know, it's like environment variable, something. Really no some homegrown crazy stuff. Configuration again, defined, platform independent, I'm happy. And also, you know, underlying protocols were standardized business services as proper microservices. So as I mentioned, we use a standard for RPC, JSON RPC2, and our JVM services didn't leak any crazy stuff like, you know, data types, JVM or something through the contracts. It was JSON, so it was really relieving there. Sorry. I'm used to writing code, not talking that much. So decomposing. Again, there was the task was never to do some decomposition thing, right? It was adding Node.js. So there would never go to decompose, fix, or re-architect existing stack. The goal was just to introduce a new one, to be faster in some places, to be leaner, maybe being able to deliver stuff faster, and the composition happened actually just a side effect, and is a side effect if you want to actually be leaner and go faster in the future. You know, Node.js is not the end for us. I mean, if I'm doing my job right, adding next stack hopefully will not be a year. And no crazy reverse engineering stuff as well. So again, when I started, it was just, let's see, you know, how hard that is. Is it doable at all? POC. So this is actual code from like 1,000 commits back. I just looked some, and you know, there are some, it was TDD. I mean, this is what we do at Wix. I don't know how to do it differently now, but there were, you know, talk to this, add this. Thing is like the load balancer is asking your service, are you alive, right? Is alive, and the thing was basically just say, I'm alive. Doesn't matter if all your collaborators are dead, it was still like, okay. So this was POC. I mean, and a lot, like, you know, just trying to get off the ground and see what can it be done. Then for the fat clients, there is a pattern when dealing with fat clients that I think Twitter used when adding Node.js, sidecar. So basically you JVM, shove all the fat clients to it, and deploy it with your service. So it's like, you know, double-headed thing. And then, given it's like local, you can talk via IPC, and the performance benefits are there. Development, I guess, experience is terrible. Production operations are mostly crappy, but still, but it's really fast. What we did, we actually moved initially the fat clients, the P tree I mentioned, the AB. We built a service and moved the fat client there. So again, and not service that is deployed locally, but just microservice, fat P tree microservice. And initially, you know, it was just, let's cover the bare minimum to actually be able to write a front-end server. So there was something about languages, being able to communicate over RPC, obviously in microservice architecture, aspects doesn't really matter. Ops contracts, so you can deploy, redeploy, build your thing. And given in Wix, there is interesting thing. If there is something available somewhere, you know, package in registry or some Git repo, somebody will find it and start using it without asking, and it's fine. I mean, if you put something, people might just use it, and then of course you have to deal with them. So this is what happened in this case. I was still building the thing, not talking about, you know, production anything, and people noticed, and hey, you know, there were some brave souls. I want this Node.js thing, you know, screw backend developers. Now I can do the thing myself. And they actually started building stuff, services, and deploying to production. I mean, I would consider that thing not ready, but it was working mostly. I mean, with some rough edges. And then, you know, ooh, shit, I have to do something about it. So I had to make those like fully working things, add additional things so people can actually run the thing in production, like monitoring, for example. If you don't have, you know, I don't envy you really. And then what I did in this case, I just, given the JVM was our primary official stack in organization, I just built test kits of JVM. So if I want to make sure that RPC communication works and doesn't break, I just build myself a test kit via JVM and, you know, run tests. If developers in JVM change something, like break me, then it's my CI will break, and then I will know immediately. You know, just to make sure I get the feedback, possible desynchronizations between things as soon as possible. And you know, because sometimes they might do without knowing. If they do it intentionally, they will tell me, obviously, but just by accident. And it served me well. It was like way better than, you know, just some unit test or something where I re-implemented by reverse engineering. This one is actually, you know, giving you some feedback about the state of your thing. And then actually we said, hey, we think this thing, you know, this is ready. We like the initial clients services are working for several months already, half a year. We feel like we've done the things implemented, what needs to be there to run it in production, and then people really noticed. I mean, I'm talking about new services, like several services at least starting every week, you know, being built on it. And the thing in Wix is that from nothing to production, it's full self-service. I mean, I can just create a repo, do something, configure, and get to production in an hour, something with actual working service. I mean, it's not doing much, of course, in an hour, but it's actually there, and it can serve traffic. So, you know, people start taking it, and, you know, I know that in 3 months, there will be much more of a services in production. And the cost of breakage is even bigger there. So this is where the compliancy tests are born. And the compliancy tests is a suite of tests that basically verifies is the pattern if the platform can run in production. Is it compliant, right? Does it behave? And in our case, from outside, there must not be any difference in is it Node or JVM. It must be like the same, basically from the APIs, from behavior. So we decided, you know, to do the compliancy test, platform agnostic, so that there is no really preference to any of the platforms. It doesn't have opinion, but we wrote it in Scala because we had a lot of build-up for testing, test kits, like everything there. And also, yeah, you can exercise any platform, and also we have like bunch of backend engineers that can contribute. So this was always, I mean, I think the best thing, like the most right thing, would be to write it in something like Python, right? Because then there is really no preference to the platform. But you know, we are a bit pragmatic there. And if you look at it, like these are actual compliancy tests. No Node, no JVM, there is no talk about that, right? These are really generic about behavior. And currently, I didn't check the last number, but like Node I think is in better state. See? Node is not really compliant. It's not important, it's fine. But at least now I know. I mean, then you know we can have an opinion. Like, is it a breaking thing or is it fine? I mean, because some behavior might be something we don't really even expose right now for the clients to use. And like the test suite of compliance looks like this, and the only thing there is local node service. So if you want to have and this is like platform specific to run a service, right? If you want to have Python microservices, you take this, copy paste, implement local Python service thing, and you're good, basically, because tests are really generic. And even if you, so the Node.js was built like a front-end service initially. And if you want to use Go for only backend microservices, then of course you might not need some stuff like internationalization. Don't care about that in the backend, web. So you can even, you know, just take part of it and really, you know, then iterate and build your like a new platform, do the build up, and at some point in time you're green. Okay, we're good, we can go to production. Then we had a lot of, you know, discussions about what is a contract, what is not, because again, this is if you get multiple engineers in a room, they can talk for hours about that. So in our case, you know, we deem it to be a common behavior exposed by both platforms via public API for client, other service, or human systems. So that we don't care pretty much what it does internally, not interesting, only the outside is important. And the compliance it has is like a bit monolithic right now, right? A single test suite for all the concerns. I mean, this is how you start, right? You build a monolith and then decompose it. We're looking how to break it up at some point in time. It can be, you know, cross-cutting concerns by you know, moving to some compliance to the clients, for example, make it their problem, or categorize by layer. So we're looking at it actually, but still not there actually. And I think that now, being Wix, we're at the junction. Because we can either continue, you know, this Petri fat chubby client I mentioned, we could have not done any of the compliance things, right? It's extra effort and it's not even fun to do. And you know, we could just continue building fatter and fatter client until it got as fat as this one and could actually even talk to this and drop this one. But I'm not sure I want to be in that place. You know, I would say it's much better to build like a compliance, and then whatever of these does is not really matter. Fat, thin. Basically, there is a thing that tells you, are you compliant and can run in Wix production, or are you not? Just really simple binary answer. So that we could actually pass a litmus test. Can I actually take a team of engineers who are interested in X becoming a legit thing in my service and actually build something without convincing the rest of the company. Because if to do your job, you have to convince somebody, in most cases, you'll just stop there. You won't go, to next step, to building it. And, I want to actually, for us, to be in a place where, given some next thing that makes sense for our environment pops up, let's say go. We could do it properly without reverse engineering, and basically just some team decides it makes sense, and they just build it without talking. I mean, of course, it would cost money and everything, but if team can, afford it, screw it. Thank you. Questions?
Hi. For me, it feels a bit counterintuitive that introducing new stack makes you fast and lean. Can you maybe comment on that?
Okay. It's not free, right? So there is no free food, because if you're on one stack, then the cost of improving it, adding stuff is just like one. If you have two stacks, then it's double, right? And it might slow you down in that regards. But I was more talking about, let's say, building new services, right? So now we have a lot of front-end engineers that know JavaScript, they know Node, and even so we had some not problems, but usually challenges when building an app and iterating over it. Front-end engineer has to talk to back-end engineers for the HTTP APIs for the front-end, and it's forth and back sometimes. You have to agree, and then this back-end engineer starts talking REST and haters and everything, but you just need data sometimes. So if we thought, if we enable for front-end engineers to build their services, the feedback and iteration is much faster. I mean, because we have hundreds of microservices, and for core data, there is usually something. And in most cases, it's just calling them, assembling data, transforming and pushing out. So in that regards, the speed of delivering new products, not in all cases, of course, actually improved. And another thing that I mentioned that it happened by accident, but React server-side rendering. So in some cases, let's say, we have challenges in performance. Let's put it that way. So now, I don't know exactly which part, but part of our mobile traffic it's served through Node, React SSR, and the performance really improved. I mean, we're talking times there, basically. So this is another facet of being fast, right? This is just performance, but I don't know. Maybe we could have achieved that via JVM, maybe, but again, and even it enabled us to build some new innovative products as well.
Next question.
And you talked about the compliance tests, and with microservices, you said you just gather some data from, get some data from, I don't know, queuing or other service, and transform it and push it somewhere else. How about the compliance tests? How do you do you test all the workflow to some business result, or just for one microservice, or?
No. So the compliance tests are more about running in production. I'm not talking about exact instances of the apps. I'm more talking about I'm doing an RPC call to a service. Am I doing it right? Because I showed the picture where you have send the headers and sign the request. Am I doing it right so that the thing that I call will behave properly. Because if I'm not doing it right, some piece is missing, and he will still accept, but he might, one example, for example, user session or authorization date, right? So if I won't send it, in most cases, he might even return something. He just say, hey, it's not authorized. So he might, fall back or do something different. But of course, I want to make sure that if user is authorized on the top, the needed information is traveling down, the line. And compliance tests were also, and same for, P3, like conducting experiments. So this is not like business APIs or something. This is basically just behavior. If the experiment, Markov experiment is being sent, are you behaving in a way, that you should? So of course the compliance tests, like specific apps, are built with a predefined contracts so that compliance tests can probe you in a, no, because a lot of stuff is internally. So you do something, you check through other side or through like if RPC call, through the third collaborator. So they are a bit to work with, but